Good morning, everybody. In previous class, we know about the definition of a limit of a sequence and also whether a convergent sequence is converged to a unequal limit. In this class, we discuss about some problems on limit of sequence. Let's take one problem. Find the limit of the sequence whose nth term is 1 by n. So solution. So I have to find out the limit of the sequence whose nth term is 1 by n by using the definition of a limit of a sequence. Let's choose xn is equal to 1 by n and epsilon should be greater than 0 for all n belongs to n. We know that the definition of a limit of a sequence, for every epsilon greater than 0, there exists a positive integer m such that modulus of xn minus 1 by n is less than epsilon. Now consider modulus of xn minus 0 is equal to modulus of xn minus 0 is equal to what is the value of xn? 1 by n minus 0, which is equal to 1 by n less than epsilon. If already have taken epsilon is greater than 0, 1 by epsilon, n is greater than 1 by epsilon. If I have to choose there exists a epsilon greater than 0, there exists a positive integer. Therefore, if m is a positive integer, if m is a positive integer which is greater than 1 by epsilon, then modulus of xn minus 0 is less than epsilon for all n is greater than or equal to n, which implies that limit n tends to infinity xn is equal to 0. Therefore, sequence xn is converges to 0. This is the first problem. Let's take that is we have to finding the limit of the sequence whose nth term is 1 by n by using definition of limit of sequence. Let us take another example. This is a type 1 example. Let us take another type example. Second one. Find the limit of the following sequence. It is 0.3, 0.33, 0.3333. Find the limit of the following sequence whose nth term is following sequence whose nth term is 0.3. Therefore, solution take xn is equal to 0.3. xn is equal to 0.3, 0.33, 0.333 dotted line. So this can be done as 3 by 10, 33 by 100, 333 by 1000 dotted line. If you take xn 3 as common factor, we get 1 by 10, 11 by 100, 1 by 1000. So xn is equal to 3 by, this can be written as 1 can be written as 10 minus 9, 10 minus 1 can be written as 3. If you take 9 as common factor, here 10 minus 9 by 10. So the multiplication we get same thing. So this is 100 minus 1. Sorry, this is 1. 100 minus 1 by 199, that becomes 1000 minus 1 divided by 1000. So for this again, here we have taken the common 1 by 9 as common factor. Therefore 10 by 9, 10 by minus 1, 100 by minus 1, 1000 by minus 1. So the next we take xn is equal to 3 by 9. That is, we get here 10 minus 1 by 10, 100 minus 1 by 100, 1000 minus 1 by 1000. So xn is equal to, is the nth term, 3 by 9, limit n tends to infinity. So the nth term here is given by 1 minus 1 by 10 to the power of n as limit n tends to infinity. So limit n tends to infinity, xn is equal to 1 by 3, as n tends to infinity, this term becomes 0. Therefore, it is 1 by 3. Therefore, implies that sequence xn converges to 1 by 3, 1 by 3. This is a type 2 example. I will take another example. Type 3. So third problem. If sequence xn is convergent sequence, find the limit of the sequence where x1 is equal to root 2 and xn plus 1 is equal to root 2 plus xn. See, already they have given sequence xn is a convergent sequence. Given sequence xn be convergent sequence. So it implies that limit n tends to xn is equal to n. It implies that limit, since n terms of converges, n plus 1 also converges. xn plus 1 also converges to same limit. So by the problem they are given, xn plus 1 is equal to 2 plus xn. As n tends to infinity, since the sequence converges, xn plus is converges to the one 2 plus n. So squaring both sides, L square 2 plus n. L square minus L minus 2 is equal to 0. So this can be written as L square minus 2L plus L minus 2 is equal to 0. L is common factor, L minus 2 plus L minus 2 is equal to 0. That is L plus 1 is equal to L minus 2 is equal to 0. That is L is equal to minus 1 or L is equal to 2. Therefore, it implies that the limit as n tends to infinity, xn is equal to 2. The limit of the sequence is 2. These are the problems we can solve by using the definition of a limit of a sequence. Thank you once again for all to listen this one.